Hello everyone. We are going to continue our discussion of the place value systems, and in particular we are going to talk about the Babylonian system and learn how they used the place value logic. Now we've already discussed place value systems in a previous recording using the example of the Hindu Arabic system, which has been widely adopted around the world as a system of numeration. This Babylonian system, which preceded the Hindu-Arabic system, also follows the same logic, except they use a base of 60, whereas the Hindu-Arabic system used a base of 10, resulting in what's called the decimal system. But let's study first the numerals in the Babylonian system. There were just two numerals that the Babylonian used to represent all the different numbers. One of them was this conically shaped vertical line, which had a decimal equivalent value of 1, and then the other one was a left pointing arrowhead, and that had a value of 10. Now, the Babylonians also used subtraction in configuring different numbers, and they also had a specific symbol to indicate subtraction, and that was again a conically shaped straight line with a small right pointing arrow above it. Now, we also learned that the Romans would also support subtraction, but they didn't have a specific symbol to represent that operation. All they did was they would put the lower valued numeral to the left of the higher valued numeral to indicate that there was subtraction involved to determine the value of the number. All right, but here in this case they have a specific subtraction symbol they would use, and they would show in the representation of the number. So let's see how they formed different numbers using just two numerals and the subtraction symbol. So to indicate the number 2, that was pretty simple. All they would do is they would write two of these vertical lines. So let's say they want to represent 2, they would just simply put a straight line, conically shaped straight line, two of them. So each of these vertical lines represent 1. So 1 plus 1 added would give us the value 2. So two straight lines indicated 2. What about if they wanted to represent the number 11? They would use their symbol to represent the number 10, followed by the vertical line, which is 1, and then 10 plus 1 would amount to a value of 11. What about, let's think of another number that used subtraction. The number 8, all right? 8 would be formed using the subtraction operation. 10 minus 2 is 8, correct? 10 minus 2. So the way they would write that is they would first put their symbol to represent 10, and then they would use their subtraction symbol to indicate that it's 10 minus, the value is 10 minus, followed by two of these vertical lines representing 1. So here we have two of the vertical lines. So that's 10 minus 2, right? 10 minus 2. 1 plus 1, 2. 10 minus 2 would give us a value of 8, right? Now, think of each of these set of numerals to be a digit, and they would separate the digits by a space. They would put space between the set of numerals, and those would indicate separate digits. So 8 was a digit, 11 was a digit, 2 was a digit if there was a space between them. But if there wasn't any space, then it would represent a single value digit. All right. Now, to determine the value of this entire numeral set of numerals, they would use the place value system, which would use base 60, but it worked very, very similar to the decimal system or the Hindu-Arabic system. So the extreme right-hand set of digits, so the set of digits positioned in the extreme right-hand side would have a place value. All right, so now here we are talking about the place values or the positional values, would have a place value of 60 raised to the power 0. So instead of 10, which was used in the decimal system, they used 60 as the base, and it would be 60 raised to the power 0, 60 raised to the power 0, and that would have a value of 1, correct? Any value raised to the power 0 ends up being a 1, correct? The next one would have a positional value of 60 raised to the power 1, and then the one to the left would have a place value of 60 squared or 60 raised to the power 2. So to determine the value of numeric value of the entire set of numerations that we have here, you have to take the value of each digit, in this case 8, and multiply that by 60 raised to the power 0, correct? The next one to the left has a value 11 for its digit, so it has to be multiplied 11 multiplied by 60 raised to the power 1. And then the next value to the left is a 2, so it would end up being 2 raised to the power 60 squared. All right. And then once we figure out these individual values, we would just add them up to get the final value of this entire set of numerals. So 60 squared is 3600. All right. So what we are doing is 2 multiplied by 3600. 60 squared is 3600 plus 11 times 60 raised to the power 1 is 60. So 11 times 60 plus 8 times 1. Again, not 8 times 60, it's 60 raised to the power 0, which makes it a 1. So 8 times 1. And then we do the multiplication here. 2 times 3600 is 7200 plus 11 times 60 is 660 plus 8. And then we sum them all up to get a value of 6 plus 2, 8. So 7868. So 7868 is the decimal equivalent of this entire pattern of numerals in the Babylonian system. All right. So this is how you would go about converting from a Babylonian system to a decimal system by using place values based on 60. So 60 raised to the power 0, 60 raised to the power 1 as we go from the right-hand side to the left-hand side, just the way it works in our modern decimal system adopted from the ancient Indian system. And then we add them all up to get the final value. All right.